All right, today we're doing 12.3. Our purpose statement: the student will be able to sequence the steps to find the indicated term of an arithmetic sequence and the sum of an arithmetic series. So we have a lot of new terminology in this section that we haven't worked with before. So our vocab, the first one, an arithmetic sequence is when the numbers in a sequence differ by the same number. So an example would be 7, 11, 15, 19, 23, where it goes up the same every time. So you can see arithmetic sequence. This is arithmetic sequence because I add 4 to 7 to get 11, add 4, add 4, add 4. As long as it's increasing or decreasing by the same number every time, then it's what's called an arithmetic sequence. The common difference, which is an italicized D in the book, the difference between two numbers in an arithmetic sequence. So if you take any two consecutive numbers, most of the time we'll just take the first two, and you just take A2 minus A1 will give you the value of D. So in this case we go 11 minus 7 equals 4, and so we're adding 4 every time. As you look at this, if it's going up, then it's going to be a positive number. If it's going down, it will be a negative number. So that's the common difference. And then in an arithmetic series, the difference between it is it's the sum of the numbers in an arithmetic sequence. So if we have an arithmetic sequence, then the series would simply be adding all those numbers up to whatever point we want to take it out to. Okay? So those are our terms. Arithmetic sequence, the numbers that increase or decrease by the same every time. That common difference is the number it's going up by or down by. And the arithmetic series is the sum of all the numbers. So, as we get into the work, the numbers in arithmetic sequence are written as this. Now, this is important that we understand. This is a sub 1, a sub 2, a sub 3, a sub 4. A sub n is just some location out there. The important thing is a sub 1 is the number. So if we go back to that sequence, a sub 1 in this case is 7. It's the value of the number in the first spot. A sub 2 is the value of the number in the second spot. So this would be 7, 11, 15, 19, and so on. That a sub n is just, we're going to pick a spot out there. If it's a sub 15, that would be 15 spots out. What is that number? Now, because we're adding one to these subscript numbers to get the next number, if this is a sub n, the number in front of it would be a sub n. We'd subtract 1. If we wanted to go 2 in front of it, it'd be a sub n minus 2. So if we went above it, it would be a sub n plus 1, because you'd add 1 to whatever n is. If it's the number in front, you subtract 1 from whatever the number is. So, the first thing they're going to ask you to do is they're going to give you a sequence of numbers and ask, is it arithmetic or not? So, to do that, our steps are find A2 minus A1, which gives us our D value. And then if the difference between any two consecutive numbers is the same as step 1, then the sequence is arithmetic. So an example in the book, if you were to look at the first example, it says -3, 2, 7, 12, 17, dot, dot, dot. So all we do is we take A2 minus A1, so 2 minus a -3. Remember, if it's minus a negative, it becomes plus a positive. So in this case, this is 5, so that's D. Now we just check. If we add 5 every time, do we get the numbers in the sequence? So 2 plus 5 is 7, 7 plus 5 is 12, 12 plus 5 is 17. So from the information I get here, this would be yes, because it went up by 5 every time. So an example of one that wouldn't work, -4, -12, -24, -40, -60. So again, if we take a2 minus a1, that would be negative 12 minus a negative 4. So that would be negative 8. If we add negative 8 to negative 12, we'd get negative 20. That's not negative 24. So as soon as you find one that doesn't work, then the answer is no. It's not an arithmetic sequence. So those are pretty easy. Find D, see if it holds for all the problems. If yes, yes. If not, then it's no. The second thing that they're going to ask you to do on this assignment, to find the next number in arithmetic sequence, use the recursive rule. Recursive means just to find the recurring pattern that's happening. The rule would be a sub n equals a sub n minus 1 plus d. Now, you're really not going to use this one very often. If we go back to that first pattern I had up there, if I ask you to find the next number, you would just say, well, d is 4, so I'll add 4 to this, and 23 plus 4 would be 27. So they're very seldom going to give it to you where they just give you a series of numbers and then say, what's the next number? But if they do, that's how you do it. So you won't use this rule very often, all right? But you could if they just ask you to find the next number. The more common thing that we're going to use is the general rule for arithmetic sequences. If we want to find the nth term, so that's a sub n of an arithmetic sequence is given by a sub n equals a sub 1 plus n minus 1 times d, where a sub 1 is the first term and d is the common difference, and a sub n is how far out we're going. So, an example of that, if we gave the sequence 32, 25, 18, 11, and I ask you to find a sub 10. Okay, so we want to find the 10th term. So we can just use this formula. Now I've seen this before. People find out where D is and they just fill out the space until they get to 10. And that's fine if you want to do that, but not very practical if you have to go out a long way. So if we use the formula, a sub 10 equals a sub 1, the first number in the sequence, 32. Okay, this is our a sub 1. Plus, now this is where I see people have difficulty on n. Remember, n is from here, it's a sub n. So since this is a sub 10, n is 10. Minus 1 times d, which we have to find, but we know how to find that. 25 minus 32 is a negative 7. So we just plug in the formula, and we can locate the numbers. So this would become 32, 10 minus 1 is 9, 9 times negative 7, so that's 32 plus a negative 63 gives me negative 31. So you can see, using the formula, you just plug the numbers in, and you can find the values, and it's not too bad to do. So pretty easy if they give it to you that way. So now, how can they make it a little more difficult? Another thing they'll do is they'll give you this information. And they'll ask you to fill in the missing spaces. Okay, and there's ways you can do it, but using the formula, our a sub n, remember your a sub n is how far out you're going, so we're going to negative 17. So that would be, now we know that, our a sub 1 is the first number in the sequence, 11, plus n, remember n is the number of spots out we are, this is 1, 2, 3, 4, 5, so 5 spots, so that's a sub 5, and so our n is 5, minus 1, and now we can find d. So we subtract 11, negative 28 equals 5 minus 1 is 4d, divided by 4, so our d is negative 7. And so now we can find the numbers by just subtracting 7. So 4, negative 3, negative 10, negative 17. So we know we're right. So when they give you this, you're going to use the same formula we did to find a sub n, but you're going to use it to solve for d so that you can fill in the empty spaces. The next thing, a little bit more difficult. They give us this information. They ask us to find a sub 6, so we want to know what that is. And the information they give us is a sub 9 equals 120, and a sub 14 equals 195. So we're trying to find a sub 6, but we don't know a sub 1. We know n would be 6, but we also don't know d. So there's two things we don't know, so we have to find that out. And it gets a little bit tricky on how to do that because we have a sub 9 and a sub 14. So what we do is kind of like the blank part. We're just going to change this and start right here. And we're going to say, let's make this a 1. And to get to 14, that's adding 5, so we add 5 here, and so we say A6 is 195. So we're adjusting these so they fit into our formula. Now we can plug them in. 195 equals 120 plus n, which is now 6, times d. So we subtract 120. We get 75, 6 minus 1 is 5d, and we subtract, or divide by 5, and we get 15 equals d. So now we have 15. We still need to know, we know d, but we don't know a1, and we don't know a sub 6. So now we're going to use d to find a sub 1. So let's go back to the formula. And we're going to find, we're going to start, it doesn't make any difference which one you do here. You can make this a sub 14 or you can work a sub 9. It won't make any difference. I'm going to do a sub 9. So a sub 9 is 120 equals a sub 1, which we don't know, plus, now our n is 9, minus 1 times d, which we know is 15. So this would be 8 times 15. So we get 120 equals a1 plus 8 times 15 is 120. Subtract 120, so a sub 1 is 0. So now that we know a sub 1 and d, a sub 1 and d, we can go back to this formula and plug it in to find a sub 6. So let's do that in blue. A sub 6 equals a sub 1, which is 0, plus n, which is 6, minus 1 times d, which is 15. 6 minus 1 is 5. 5 times 15 is a sub 6 equals 75. So you can see we had to manipulate this into a format we could use in our formulas. So if you have something like this where you don't start at A1, just start over, reclassify it. A9 we switched to A1, which made A14 become A6. And then we use that to find our D, then found our A sub 1, and then we found our A sub 6. So you can see we use the same formula. We used it here to find D. We used it again to solve for A1. And then once we knew A1 and D, we could go back and solve for A sub 6. So it's a lot of work that you have to be careful of, but you just use the formula and adjust the numbers so you can put it in the formula to use. The last thing we're going to do is we're going to find the sum of an arithmetic series. So we're going to take a sequence, arithmetic sequence, and we're going to add up all the numbers to find a sum out to a certain location. So to find the sum of an arithmetic series, this is written as the sum of the however many, if we want the first 10, it'd be s sub 10, equals n, again, how many spots out we're going, and then it's times a1 plus an divided by 2, where n is the number of terms, a sub 1 is the first term, and a sub n is the nth term. So let's take a look at the book, and there's two different ways they can write these. So one way is to go s of 15, 4, and then, so this is saying find the sum of the first 15 terms, 4, and then they give you a series, 25 plus 12 plus -1 plus on out. Okay? So now we just go to the formula. S of 15, that's what we're trying to find. N, which we know is, remember n is S sub n, so that's 15. A sub 1 we know, 25 plus, but now it asks for A sub n. Well, remember, we're going out 15 terms, so we have to find, in this case, it's A sub 15. So again, we go to our formula. So let's do that right here. A sub 15 equals A sub 1, which is 25, plus n minus 1, so 15 minus 1, times d. Our d is 12 minus 25, so a negative 13. So we get 25 plus 14 times a negative 13, 169, negative 182. 25 plus a negative 182 is a negative 137. Divided by 2. So we had to use this formula again to find A sub n so that we can find the sum. So now if I plug this in, 25 plus a negative 132 is a negative 112. Wait a second. 157. Sorry about that. (25 minus 157). 25 minus 182 is 157. So 25 minus 157 is a negative 132. Negative 132 divided by 2 becomes 15 times 66, negative 66, which is a negative 990. Okay? So S of 15 equals a negative 990 if you add all the numbers up. So, again, format, we're using this formula, S sub 15, that gets our N 15, A sub 1 we had from the formula, or from the series, A sub n we had to plug into the formula to find it, and then we just calculate it. Now the other way they'll write these, so this is one way where they give you the sum of the first 15 and they'll write it this way. The other way that they'll do it is this. So, don't panic on this. If you've ever worked with Excel and you want to add up all the columns in a row, or all the cells in a row or column, you use this symbol. It's the sum. And so the way this is read, it says, find the sum from the first to the 12th term. So what we're finding here then is we're finding S of 12, because it's there. And these are really easier to work with than the other one, because on the other one, remember, we had to find the A sub n. Well, now it's pretty easy. So S of n equals, again, we know our n is 12. And then to find A sub 1 from our formula, we just plug 1 in. 4 times 1 is 4, plus 3 is 7. So that's A sub 1. And to find A sub n, you plug 12 in, the top number. 4 times 12 is 48, plus 3 is 51. Divided by 2. So this becomes 12. 58 divided by 2 is 29. And 12 times 29 290, 58, 348. Okay? So this S12 is 348. And that's what you're doing. So there's a lot of things. To summarize this, we've had 4 formulas. A2 minus A1 equals D. Remember, you can use any 2 numbers. You take the second number minus the number in front. That will give you D. We have this formula, which again you won't use unless it's a very easy problem. To find A sub n, if you know the number in front, you just add D. That's what you do when you're filling in the blank spaces. More often than not, you're going to be using this formula. And the last formula is the sum. So if I was doing this, I would put these on the top of my assignment because that's the formulas I'm going to be using for this assignment, so you don't have to refer to your notes on that. As long as we make sure we remember that A sub n is how far out we're going. A sub n is the value of that number, n is the number of spots out it is. Okay? So your assignment is page 844, numbers 21 to 35 the odds, and 38 to 44 all. There's also a worksheet on that. You can just get that from me. But this is due the next class period, and the worksheet, you had more time on that. So good luck on that. Again, there's examples in the book.